Today we are going to talk in this first session, philosophical session, about how Copernicus saw the world. And first of all, I would like to welcome warmly all our invited speakers and panelists, because they accepted this not easy task to shed some light on the person of Copernicus, his mind, his intellectual environment and influence. They are all experts in different fields, so this light will come from different perspectives. Let me welcome warmly Professor Andre Goddu from Stonehill College, Easton, Massachusetts, in the US. He is a historian of science and philosophy. In particular, he has been studying the works and ideas of Copernicus for many years. He published a book and many articles on the patron of our conference, Copernicus. He maintains a long-standing relationship with Polish scientific community working on Copernicus and his legacy. He is currently publishing in English translation of the work Mikołaj Kopernik by an eminent Polish Copernican scholar, Ludwik Birkenmeier. I extend my warm welcome to Professor Gulizia, Stefano Gulizia, from the University of Milan, whose interests focus on the history of early modern science and Renaissance intellectual culture. He taught extensively in the US, had fellowships in many universities, many countries. He was also a resident in the Polish Academy of Sciences in Warsaw. Looking at his bibliography, extensive bibliography, his works, I saw that he wrote also the traces of the Sphera in early modern Poland and northern Germany. So he has a relationship with Poland. He is interested also in the influence of Aristotelian thought, especially philosophy of nature along centuries. Finally, let me welcome Professor Wojciech Sady, who is working in the University of Silesia. He's primarily engaged in the philosophy of science, but also in the history of ideas. He is very well known to all of us, I hope, for his books, especially in the philosophy of science, but also he published a 3-volume history of religion, philosophy, and science, and the last of which covers the period in which Copernicus lived, from Pico della Mirandola to Michael Servetus. So, our topic is how Copernicus saw the world. This idea implies the idea of the image of the world. What was Copernicus' image of the world? Probably you know a very nice book of C.S. Lewis, The Discarded Image. And this book is also translated into Polish since many years. He is writing about the situation in which the medieval and Renaissance image of the world remains rejected somewhere between 17th and the 18th century. So now we are living in with a completely different world image. Foreign, external to our minds. So our question could be, to what extent Copernicus shared this discarded image, which he inherited along with the mentality and culture of his age, and to what extent he had and wanted to discard it in order to develop a new theory of the universe. In this context, the words of one of the yesterday's discussants, Professor Helge Krag, are quite telling. Copernicus was a thoroughly conservative and not a revolutionary person. He became a revolutionary, as it were, against himself. We can discuss it. The question about the world view is ambiguous. we can distinguish two senses at least. Narrow sense, objective we could say. What is the picture of the universe contained, involved in his astronomical work, and how it does differ from the world picture of traditional astronomy? Is it only the swapping of the place between the sun and the earth, or something more? In the broad meaning, the world image is the picture of the world every one of us is creating, developing for himself, drawing on mentality and culture of his age, education, religion. And this kind of picture of the world can combine many different disparate elements, not necessarily creating a whole that is not necessarily very coherent. I think both of these ideas are important when talking about the world image of Copernicus. He was a physician, he was a Greek geographer, economist, politician, so his worldview was very broad, going far, far away from astronomy. So now we are going to listen to 3 short presentations by our invited discussants. Then we'll try to discuss among us these ideas, and at the end we'll have the opportunity to ask questions from the audience. Professor Goddu, please give us your presentation.
Sorry about that. Well, thank you very much for your introduction and for the invitation to attend the Congress. These are special events, especially for us foreigners, and we very much appreciate the generosity of Polish authorities and the Polish nation in sponsoring these events. Let me say, first of all, that I have prepared some comments, written them out to prevent me from wandering too far afield and sticking to the topics that I've selected. And secondly, I need to make a disclaimer that, namely to the effect that I regard Copernicus's assumptions and ideas as mistaken, but they were fruitful mistakes. They helped him to critique Ptolemy and Aristotle, and to that extent, he contributed to the later advancement of our view of the universe and of astronomy. So with that explanation, let me begin with my comments. I will begin with a quotation from Copernicus and a few comments that he makes, and then I will try to explain how I understand his comments. I'm hearing an echo. Am I speaking too loudly, or okay? Should I just continue? In his dedication to Pope Paul III in Revolutions, Copernicus provided the clearest statement of the motivation for his heliocentric theory that he ever wrote. It is by his own admission obscure. Here is what he wrote. Those who employed eccentrics have admitted numerous things which appear to contradict the first principles of uniform motion. Moreover, they were unable to discover or deduce from eccentrics the principal consideration, namely the form of the world and a certain commensurability of its parts. Instead, they acted like someone who took hands, feet, head, and other bodily parts from diverse individuals, each well depicted, but without correspondence to a single body, because the parts did not fit together at all, with the result that from them they composed a monster and not a human being. Therefore, in the process of demonstration, which they call method, we discover that they have either omitted something necessary or admitted something foreign and not at all relevant. This would not have happened at all had they followed certain principles. For if the hypotheses assumed by them were not fallacious, everything that follows from the hypotheses would have been verified without doubt. Although what I am saying may be obscure, it will nevertheless become clear in the proper place. Because, he later continues, the order and size of all the planets and spheres and heaven itself is so linked together, it follows that in no part of it can anything be shifted without disrupting the remaining parts in the universe as a whole. End of quotation. The inference is justified by the topic from an integral whole. Finally, in Book 1, Chapter 4, Copernicus cautions us to examine the relation of Earth to the heavens carefully. Otherwise, we may make the mistake or the error of attributing to the heavens what belongs to Earth, thus violating the rule that permits only a negative inference from integral part to whole. That is to say, the error would be to attribute to the whole that which belongs only to the part. He repeated a view about the relationship between a hypothesis and consequent that relies on a connection, or at least a relation of relevance between the if clause, the antecedent, and the then clause, the consequent. According to Copernicus, the consequent cannot be true unless the antecedent is true. If the antecedent is false, then the consequent cannot follow from it. The implication strikes most people as intuitively sound and even as common sense, but most academic and mathematical logicians reject this interpretation because they judge the validity of hypothetical arguments and consequences in terms of the independent truth value of each part of the consequence. In other words, a true consequent can follow from a false antecedent. Copernicus understood Ptolemaic astronomers to state that if the planetary models are false, then we can still trace the planetary paths and make adequate predictions of their future positions. Now, there is something of a discrepancy between Ptolemy and Aristotle in this regard, for Aristotle maintained that the true agrees with the true, and that sooner or later, a false view will be contradicted by the facts. Ironically, however, Aristotle's vision of the universe was built on a fallacious foundation. Copernicus's justification for his view rested on an interpretation of consequences by a professor at Krakow in the late 1490s, John of Glagovia. He does not cite John specifically, but there is a strong resonance between the views that John defended. John argued that the validity of a consequence depended on the connection between an antecedent and a consequent, and on the following of the consequent from the antecedent. To justify this interpretation, John maintained that the connection or the following depends on the meaning of the terms, so a semantic criterion, and on the relations such as integral whole and integral part. The relation of an integral part to an integral whole follows certain rules. The first rule is, if a whole exists, then the parts exist. For example, if a house exists, then a wall exists. This rule is stated in the following way: from an integral whole, we may argue constructively that the parts exist. The second rule is that if a part exists, we may not conclude that the whole exists. For example, if a wall exists, then a house exists. That implication is false because a wall may be standing, but from that fact we cannot know that a house is also standing. The house may have been destroyed, leaving only a wall standing. So the rule here states, from an integral part, we may not argue constructively, but only destructively or negatively. If the wall does not exist, then the house does not exist. Now, how does this relate to Copernicus's critique of Ptolemy and to his vision of the universe? Copernicus criticized Ptolemy for attempting to account for the motions of the planets by proposing geometrical models that were false. In addition, Copernicus criticized Aristotle for constructing a vision of the universe based on what we observe here on Earth and drawing conclusions about the whole universe from a part. From the part Earth and from the observations here on Earth, Aristotle concluded that Earth is at rest at the center of the universe. In other words, Aristotle violated the second rule: we cannot argue constructively from a part to the whole, but only destructively or negatively. So, in contrast to Ptolemy, Copernicus maintained that a true astronomical result can follow only from a true hypothesis. He maintained, in contrast to Aristotle, that we must begin from a vision of the whole universe to arrive at true conclusions about the parts. From the integral whole, and only from the whole, can we identify the existence and position of the parts. From this intuition, Copernicus concluded that Earth is a planet located between Mars and Venus, and that it makes an annual path around the sun. So did Copernicus believe that he had refuted the ancients and confirmed the heliocentric theory. Now, there may have been images of models that I overlooked as I was making these comments, and perhaps we can go back to the model that shows Ptolemy's relation between the sun and the Earth, with Mercury and Venus in between. I think they were in the slide somewhere. Now, later on, Michael Maestlin, in his preface to the 1596 edition of Rheticus's Narratio and Kepler's Mysterium Cosmographicum, comments on Copernicus's defense of this whole part analysis. And he comments that the teacher, as a teacher of Johannes Kepler, that he defends Copernicus, maintaining that Aristotle's inference from such a small part as Earth to the whole world is a weak argument, and promotes the view that Copernicus defends. Later, Kepler applauded Copernicus, this is in Astronomia Nova, for rejecting the idea that the true can follow from the false, and in agreement with Aristotle, concluded that with a false view, the facts will clash sooner or later. From his critique of Ptolemy's method, namely of basing astronomy on false models and also on false assumptions about the universe, and from his critique of Aristotle's conclusion that Earth is the center of the universe, Copernicus proposed an alternative method that began from a vision of the entire universe to construct a new image of the form of the world and the certain commensurability of its parts that arrange the parts in a harmonious way according to a unique mathematical principle. Thank you.
Okay, that's better. Okay, sorry about that. I was trying to avoid the echo problem. So I'm very, very happy to be here. I really feel a lot of generosity, and the room, this anatomical place, is very intimidating as well, and Andre Godu and everything like that. I thought for a reasonable time to disguise. I have something new to say, or relatively new, whatever is new for Copernicus, right? It's debatable, but I'll try to disguise it. And I think, given the setup here, I'll give a talk in 3 parts. The first part wants to answer to the question of the panel. How did Copernicus see the world? I think we can answer in 2 ways. One is negatively. I feel fairly certain that Copernicus did not see the world as a Neoplatonist. I think this is, at least in the hard, militant way that some scholars are trying to make him sound like, I think that we don't possess sufficient evidence that he saw the world like that. And one problem that I would bring up is that a lot of our scholarship seems to be concerned with later Copernicans and their agenda, and then writing back to Copernicus with something like Kepler in mind. And this is a real problem, because there is Copernicus is writing at the beginning of a massive revival of ancient learning, but he did not avail himself of many of the editions. There were simply too many things that were not available to him, and I hope I'm not detracting from Copernicus as a hero of this group by saying that he did not possess enough Greek to work his way through the commentary tradition of Aristotle, for example. And has been conclusively argued, in my view, by a scholar named Knox, that he actually did not read Philoponus, for example, but he availed himself of a translation in an encyclopedia, in a lexicon, a Hellenistic lexicon called the Suda. So he finds something on the word kinesis, movement, motion, and that's what he found. And he wanted to use it again with the combining with some impetus theory, which was coming out of the scholastics, and eventually that's his way into a pretty Greek tradition that is really mediated through a lot of Latin sources. So I think this is important. I have a lot to say about doxography. I won't now, but I'm happy to come back later. When something feels out of place in a philosophical way, it's either because we don't understand it or because it comes from a tradition that has been interpolated. And so we have to look at Copernicus as a doxographer. I think this is very important. It's clear that Copernicus relies on lexica, on encyclopedia, on placita, on many things that we do not associate, and we don't need, I think, to have a strict dichotomy, which is a false dichotomy, whether he was an Aristotelian, whether he was a Platonist, or kind of middle, late Platonist. I think we need to fold back that theory into epistemic and scholarly practices, which is the reason why today I wanted to start from looking at Copernicus as someone who does primarily, is preoccupied with the commensurability between words and things. And I think there is something in Regiomontanus that I wanted to point out, where Regiomontanus talks about the faults of a translation of Ptolemy, and he says the role of the author is to find the form of accommodation. You see in the red over there, the author is someone who accommodates between the right words and the phenomena. So there is this sense of, I think Copernicus is a student of Regiomontanus. We know from various studies that in 1493, as a student in Krakow, he bound together a book and he worked on it for more than 10 years. And the idea is that I think there is this preoccupation with finding the right technical vocabulary. And so there is this idea of cleansing the theory, which is behind a lot of his thinking. And I think in a way this is connected to something that Seneca says. Seneca talks about the bona mens, the fact that before you do philosophy, you have to clean your mind from the incorrect assumptions and then move forward. So I think there is this kind of very low cosmographical, lexicographical element, which I like to sort of point out as a kind of binder of many of the more sophisticated theories of Copernicus. Now, having said that, there is a positive way to respond to the question, how did Copernicus see the world? And that would entail actually making an assumption, I think, to what is the role of vision and observation, also in the Latin technical terms of the astronomical observatio. As many of you know, there are authors like Gianna Pomata, for example, at Hopkins, who says that at a certain point in the European history of the discipline, you have a kind of mathematization and accentuation of computational techniques by which observatio become, as she says it, an epistemic genre, something divided from, secluded, severed from the earlier idea of looking at the world. I'm not sure how much of that applies to Copernicus, but for sure, if you look at the evidence, it's difficult to combine Copernicus with a line of thinkers that go back to, let's say, Leon Battista Alberti, or maybe even more, Nicholas of Cusa. I think the only evidence we have is very, very limited, and it does not allow us to respond positively to the question, which is to say, how much of the visio intellectualis, how much of that looking in the world is resonant with Copernicus. 100 years ago, Birkenmeier published the book Stromata Copernicana, a beautiful book, and he says at some point that there are notes in Copernicus' hands of a book by Charles de Beauvais that refers to Nicholas of Cusa. But as far as I know, and I'm far from an expert, this is about the only actual evidence we possess that there is a connection between Cusanus and Copernicus. And so I don't think it's enough to actually implement the idea of vision of the world in a kind of Cusanus way, so in the style of the idea mundi or idea mundi. So, but that's open to question, and I don't want to say more about that. What I prepare to do now in the second part of my talk, which looks to you confusingly as part one, is discuss a little bit of the ways in which there is a deep permanence, a longue durée of scribal technology in Copernicus. I won't be able to do much of this. It will take an hour or more just to, to go through this. But to me, it's very important to escape certain discussions and really go back to a terminology, again, an idea of how did Copernicus work, what were his instruments. And I think the history of reading, the way it gives us clues, important clues, and I think we need to escape another possible false dichotomy, which is that you either work on the reception of Copernicus or you work on the early intellectual formation. I think the two things do not need to be in contradiction with one another. There is a way to use, for example, what readers made of Copernicus, marginalia. There's a lot of marginalia that need to be studied in European archives all the way up to Uppsala. That really haven't been looked at for 30, 40 years, and they'll tell us something about the scribal technology that he used. And also, it's interesting to insert Copernicus in a history of university type of research. So you see, for example, in the Aristotelian books, this comes from Helmstedt in circa 1620s. You see a kind of subalternation of the sciences. It's a marginal note, and then the same author also works on Copernicus. I'll come to him later. You see to the left side a note which was taken on Copernicus, the theory of motion, the motion of the natural elements. Though I don't have time, my only point it would be that it looks standard natural philosophy, right? I mean, it is made in the same style that the schoolmasters and teachers at the Academia Julia in Helmstedt would teach something like Ramus or Peter Apian, or so on. So there is this kind of note-taking technique, which is also with Copernicus. Copernican theory comes into this notebooks in exactly the same way as you would find reflections on, say, Ramus and Aristotle and so on. And then finally, in the classroom, also from Helmstedt, there was a preparation of 4 diagrams. They refer to the systemata, to the world systems. And so you have Roslin, you have Ptolemy, Copernicus, and you have the Tychonic solution. This is interesting because I found other diagrammatical evidence in Uppsala, and you have to remember that in 1616, while the Roman Church bans Copernicus, at the very same year, the Scandinavian academies decide that it's permissible to actually teach Copernicus in the curriculum of natural philosophy. And the extent of that is very much understudied because there is a connection in that field over there with Paracelsian medicine in practice. And so you have a kind of convergence, again, another form of accommodation between Paracelsianism and the Copernican tradition. So I won't get to, I can't do much about that either. This is very frustrating very quickly, I'm sorry. But anyway, let me come back to something that André Godou just mentioned. He just mentioned this very text. This is the prefatory statement of Michael Meslin to the 1596 edition. As he brilliantly said and wrote in several publications, this is a validation of how you argue for a cosmological arrangement from the integral part. The main philosophical point is what you find in the second paragraph, at the beginning of the second paragraph over there. However, my comment isn't about that. It's actually, I'm interested in other things. And I like to use the next, 2-3 minutes to just try to bring some new light into this particular reception of this particular text. First of all, I would like to point out that Meslin communicates an idea that Copernicus' style is elegant. He says erudite, at least for the chapter, book 1, chapter 9, he says, Copernicus says something erudite. Now, this erudition, I think it's part of the same idea of going back to doxography. You use ideas in a kind of setting which is very known from the Jesuits, for example, to do like pro and contra, arguments, in favor and against some topic. Now, the other part that interests me is that immediately after Meslin, after he refers to the theory of the integral arguing from the whole, he also says it's pretty clear to see whether the old hypotheses are better, are more trustworthy, or the Copernican style. And he used the word usitatarum hypothesium, so the old-fashioned, those old hypotheses. Now, if we look at the next slide briefly, this comes from Uppsala, a dissertation of 1632 by a student of Martinus Gestrinius, who was a cosmologist and actually an open Copernican person. And the whole point of this dissertation, disputatio, it's a PhD, examination, if you will, in 1632, is to say whether the hypotheses are a mere mathematical figment, imagination, more or less like Osiander wants us to believe, and so on, or whether there is a physical reality attached to it. So it's interesting that the language Meslin really understands, even if it's late, writing in 96, he understands there is an operative principle there. And then immediately after, he has a series of verbs. He makes us see how Copernicus uses actual epistemic practices. And one of them, if we take this further, we find another evidence, which I think has been overlooked, and maybe I'm wrong, but there is a letter of German mathematician Rothmann, who writes to Tycho, and it's part of the Epistolae Astronomicae, which is published also in 1596. And if I'm not mistaken, there is a reference to the theory of the whole and the parts. I don't have time to read it, unfortunately, but it's there. And you can see that the argument proceeds a parte ad totum erot manus in sua epistola, etc., etc. So there is this idea that this is a reference to the same discussion, I think. And so much so that in a copy that it's here at the Jagiellonian Library, which was on the book of Tycho, the Epistole, was owned by Jan Brožek, a great fellow who also had books of Copernicus and did many interesting things to them, especially the 1543 edition of the De Revolutionibus. This one, however, is the Tycho book, and you can see, I hope, that in the outer margin, he annotates passages in favor of Copernicus and against Copernicus. Again, I think we are in this kind of classroom situation where people debate, as you say, disputatio nutramquem partem. No, I mean, that's the idea, and he has it there. He makes us see that there are passages pro and contra Copernicus. And interestingly, on page 185, there is a defense of Copernicus based on the theory that Andrei just talked about, the arguing from the integral. It's on the letter of Rothman, right? And it's if you look at the page, Jan Brožek underlines it exactly that passage. So he has a clear view that vision of Messlin is actually in the book of Tycho owned by Jan Brožek. It's extraordinary, and I think it has been overlooked. There would be more to say, oh man, but I won't do it. But there is a copy in Wolfenbüttel that has similar characteristics. So I think this is a larger debate. In fact, there is a copy. Let me finish with that. And I'm very, very sorry for the time. This is impossible. I mean, I set up an impossible task. But I wanted to end in my imagination, right? I wanted to end this talk by discussing 6 epistemic practices that I think are useful concerning Copernicus. I only have time to mention one. I mean, they're all good, and I have examples for all of them, if you can believe it. But the binding is very important. Because, and here I finish, there is a collection of Copernicus, which is bound with the cosmographical treatise by Jakob Ziegler. This is in the library of Wolfenbüttel. And Copernicus there is identified as a languidus mathematician. Languidus is a word that Messlin uses in a letter to Kepler. I feel it's 1597, where he says, I like what you're trying to do with your reform of astronomy, although my consensus is not really strong, is lukewarm. And he says, languidus meus assensus. So languidus is the Lucretian word that is used in the 5th book of the Rerum Natura to talk about the rays of the sun. So there is this joke, there is this kind of very sophisticated, again, erudite way that Messlin uses, co-opts a Lucretian word to say something about Kepler, and then a reader of both Kepler and Copernicus in Helmstedt actually uses that to identify the computational analysis of Copernicus in the margins of a bound edition that binds together Copernicus with a cosmography. So I'm really sorry for the time. I did the best I could. I'm so happy to be here. Sorry. Thank you.
Okay, the third presentation now, please, Professor Sady.
Okay, I will ask about thought collectives Copernicus belonged to, and why? Because thinking is a collective activity. There are no isolated investigators. What we do think and what we do see depends on the thought collective we belong to. So to understand Copernicus' achievement, we need to know his social involvements, but unfortunately, there are very serious gaps. And in fact, we know desperately, we are full of doubts about Copernicus' thought collectives, and there is no chance probably to fill it with documents, reliable documents, but at least we can speculate. And Professor Godwin admitted in his book that we need to speculate about Copernicus. And I will begin my speculation. Oh, this is a quote from Fleck, that there are no isolated investigators. And I will begin my speculation in 1439, when Basil Bessarion moved from Constantinopolis to Rome, bringing with him almost 500 Greek manuscripts, and many of those texts were unknown to Latin-speaking Europe at this time. Those texts were quickly translated. There were Platon's dialogues, Neoplatonic works, and also Hermetica, texts about alchemy, magic, astrology, and medicine. And because of those texts that were translated by Marsilio Ficino and others, astrology became much more influential than it was before. And two main centers of astrological thought were created. The first one here in Krakow by Marcin Król, or Martinus Ruterus, if you like, and Petrus Gaszowiec. And the second center was in Vienna, when Georg Feuerbach started his lectures in 1453 about astrology and astronomy. The only tool available astrologers needed astronomy. And you need to remember that in Renaissance period, the only reason to study the movements of Mercury, Venus, Mars, Jupiter, and Saturn was astrology. So, and the only tool for astronomers at this time was Ptolemaeus' theory. Ptolemaeus was a famous astrologer and astronomer of the 2nd century. And Basil Bessarion asked Feuerbach to translate, to make a good translation of Ptolemaeus' Almagest into Latin, but Feuerbach's knowledge of Greek was not good enough, so he started to write something like a critical abbreviation of Ptolemy's Almagest. He died quickly, but he was replaced by Regiomontanus, who finished his job. And this critical abbreviation of Ptolemy's Almagest started to be a basic textbook of astronomy at this time. Both groups from Krakow and Vienna started to cooperate. For example, Marcin Bilica left Krakow for Pest, and he met Regiomontanus there. They prepared together tables, astronomical tables for astrologers that were quite successful. They had 11 printed editions. Copernicus' book was edited only twice, and they had 11 editions. And they had followers. Oh, now it works. They had followers. I would like to mention especially Wojciech z Brudzewa, or Albert de Brudzewo, who wrote a commentary to Feuerbach's book, or a popular booklet on astronomy. And Wojciech z Brudzewa claimed 150 years before Kepler that the moon revolves around the Earth in an ellipse. And what is very important from the point of view of Copernicus is that he knew about Tussi-couple. Tussi-couple was a geometrical construction allowing to convert two circular motions like this into one linear motion like this. And Johannes Tussi was a Persian astronomer of 13th century, And there was also a Johannes Engel, who was an astrologer, and one of his astrological almanacs, he made a remark about Ibn al-Shattaya construction, similar to this Tusi couple. So, and you need to remember about it. I will return to this. And finally, we have Copernicus. We know almost nothing about Copernicus' childhood, but we know that when his father died, the brother of his mother, we don't know when his mother died. If Copernicus was an orphan already when he was 10 years old, but his uncle sent him together with his brother here to Krakow. And in Krakow, Copernicus studied probably Artes Liberales. Professor Godu tried to reconstruct his schedule. Here, we know that Copernicus was already interested in astronomy because he bought Alphonsian tables and Regiomontanus tables and at least one book in astrology. Unfortunately, we know nothing about Copernicus' contacts with Wojciech z Brudzewa or Albert de Brudzewo. And this is a very, very painful gap because then Copernicus moved to Italy. Here in Krakow, he was exposed to Aristotelianism, yes, but in Italy, he was exposed to Neoplatonic philosophy with the search of geometrical harmonies in the world. But again, we know that in Bologna, when Copernicus studied law, there were two influential astrologers. The one was Domenico Maria Novara, and Copernicus knew him. They together performed at least one astronomical observation, but we know nothing about Novara's astronomical views. So we can only speculate about. We know then in one of astrological almanacs published by Novara, there is an error, astronomical error, and some people suspect that it could inspire Copernicus. And the most important question about, again, I have problems with it. And the most important question about Copernicus' stay in Italy was if he could read or be told by somebody about two remarks that survived about Aristarchus. Aristarchus was a Greek astronomer of the 3rd century BC, and the two remarks about him survived only. One in Archimedes, who was contemporary to Aristarchus, and in Archimedes we write that Aristarchus' hypothesis is that the fixed stars and the sun remain unmoved, that the earth revolves about the sun on the circumference of a circle, the sun lying in the middle of the orbit, and that the sphere of fixed stars is so great that the circle in which, it means that stars are very, very, very far away, so that it makes star parallax invisible for us. And there is also a short remark in Plutarchus about Aristarchus, who, in order to save the phenomena, supposed that the heaven remain at rest, and that the earth revolves in an oblique circle, while it rotates at the same time about its own axis. Both texts were still not available in Latin translations, although Archimedes was translated into Latin already in the 12th century, but Copernicus had some knowledge of Greek, could read Greek at least a little. He was surrounded at universities in Bologna and in Padua by mathematicians, by astrologers, maybe by astronomers, so it is possible. And those manuscripts were available in Italy, so it was possible that somebody told him about Aristarchus' views. Then Copernicus moved to Varmia. It was the region situated 600 kilometers from Krakow, 1,000 kilometers from Vienna, and 1,700 kilometers from Bologna. In Varmia, Copernicus had no students, no fellow workers, nobody to talk about astronomy for the rest of his life. And he spent 40 years in Varmia. In fact, we know that he corresponded with Bernard Dąbrowski, but Dąbrowski was a cartographer, not an astronomer. We know nothing about his contacts with Krakow's scholars or his contacts with astrologers and astronomers from Italy or from Vienna. So he was desperately alone in Varmia. He simply performed his duties as an assistant and a doctor of his uncle that was a bishop of Varmia at this time. Then he moved to Fromborg to work as a canon, as a church official. We know that in Fromborg he performed some astronomical observations that were of a poor quality, rather. It is strange because Copernicus used only 27 of his own observations in De Revolutionibus. So he made one observation every 18 months. So it was almost nothing, and his errors were quite big. The quality of his observations were poor. What we know is that here in Krakow, Maciej z Miechowa made a catalog of his library, and there is a remark about 6 pages long manuscript declaring that the earth moves and the sun is in fact at rest. The question is this remark about Commentariolus, text now discovered in 19th century and now known as Commentariolus? We don't know it. We don't know how many copies of the text were made, who made those copies, how many people received it. Commentariolus consists of 2 parts. The first one, 10% of the text, is cosmological. The other one is the outline of the geometrical model of planetary motions. You can see that in this cosmological part, those fragments in bold can be found in Archimedes and Plutarchus, yes? And if you accept those parts, the rest becomes almost obvious. And then there is again. And then we have a geometrical part which is based on the techniques of Ptolemeus and Regiomontanus and the ideas of Al-Tusi and Al-Shatair. What is interesting is that there is only astronomy and no astrology at all. So Copernicus grew up among astrologers, but then he made no comments about astrology. He neither accepted it nor criticized it. He was simply silent about astrology. And finally, Georg Rheticus, we don't know how he got to know about Copernicus, but he came to Fromborg and he helped Copernicus to finish De Revolutionibus. In 1539, De Revolutionibus was almost ready. And Rheticus published his Narratio Prima with some astrology in the text. He presented Copernicus' system plus some astrological predictions. But Copernicus himself, in the manuscript that existed in 1539, there is a remark about Aristarchus. But sending the book for print, Copernicus removed this fragment. Copernicus in De Revolutionibus doesn't mention any of his teachers from Krakow. He doesn't mention Wojciech z Brudzewa. He doesn't mention also Novara, with whom he cooperated in Bologna. He doesn't mention about Al-Tusi or Ibn al-Shatair's techniques. So it looks like that he tried to hide the sources of his inspiration. So, and it makes it very difficult to understand what he was doing. And in De Revolutionibus, he also didn't thank Rheticus, which is also very strange because without Rheticus, the book wouldn't be published. So thank you.
Okay, we are left with only 20 minutes, so we don't have much time to discuss. But I think there are two things here that were touched by our discussants. We have this problem of the integral, the argument from the integral whole, and you have shown it as a coming from Aristotelian dialectics and went to Copernicus. And Professor Gulizia showed that it was used in a very special way by Renaissance thinkers as a kind of a topos, but related with some very strange connections with typical to rhetorics, Renaissance rhetorics, using just playing a little bit with this topos. And the second, we have the problem of being Copernicus, not maybe a completely solitary wolf in astronomy, but he's completely quiet about who has influenced him, and this can show us his mentality maybe. So let's start maybe about this integral whole, and how would you link this idea of this argument of the integral whole with the idea of worldview? Because it's a logic, largely understood. What do you think? Is it creating a worldview or shaping worldview, or
I think that it led him in thinking about the relationship of a finite, in his mind, perfect, complete, unified whole to the conclusion that the stars are stationary, and between the stationary stars and the stationary sun, everything else moves. So to that extent, I think it influenced his construction of his idea of the relationship between whole and part, and persuaded him that from the vision of the whole, and only through that vision of the whole could we decide how the parts are arranged. All right, so to that extent, I think it did have a constructive effect on him.
Yeah.
But as I pointed out, as I confessed, it's a mistake, at least from our perspective today, unless you're one of those quantum cosmologists who also thinks of the universe in some sense as a whole.
Okay. Thank you.
I would just briefly, it's a great question. I think that is the question of seeing from above comes to play a role in the visualization of the cosmos, in the sense that Peter Apian, has this distinction between the way the cosmographer views things, which is, it related to this rhetorical, logical, enabling discussion, pre-discussion of whether you see from the parts or the whole. And I would say that if you look at the way that the textbooks of astronomy were visualized from Sacrobosco all the way to the 1520s and the 30s, you see, for example, that the elements are placed in a way that underlines their mixture. So, for example, the water and the earth becomes a terraqueous part.
Yes.
And before, if you look at medieval manuscripts and things like that, they were not, right? They were separate. So this is an idea that goes already into play some role, because in fact, here I will end. Copernicus is so adamant about the idea that the natural movement of the elements is circular, that the rectilinear one is like a disease, is a sickness of the body. And there's a beautiful quote that is, an element goes back to its natural place. So cartographically speaking, that also has a visualization problem very quickly, and he does it like an animal who is sick. And he says, like egro animale or something like that, sicut egro animale. Now, in edition of 1614, Nicolas Moulier publishes equo, not egro. This is a textual variant. It's what philologists would say, it's a lectio difficilio. But it shows just how much of Europe was reading Copernicus through the preoccupation of equalizing. Equalitas, equo is everywhere. I think 80% of the variants on Copernicus text really mention equalitas. That's the main thing. So when you visualize the cosmos, that's the first principle. I think the discussion of the integral plays a role into this, I don't know how to say it, but equalization or making movement equal, standardization of the world. And just one final comment about the role of think tank and friends. There is actually a very specific part of a letter that is alluded to by Copernicus, which is a letter, a pseudo-Pythagorean letter, where he says about something committing to the friends with the hand, like committing notes. If we look again at the marginalia of Copernicus, you see that there are authors like Paul Wittig, for example, who completed a whole set, and then it was passed on to another theoretician working in another city, and they prized the idea of having a complete set of marginalia to Copernican work textbooks. So there is a role, I think, to study these circles. You don't just need to do the traditional intellectual history of where he studied, what did he know, etc. But you also have to look at what the readers made of the text and how they share the information with other readers, because that's primarily how the Copernican project became a European shared project, through sharing the marginalia with friends. And we know Tycho wanted to buy the library of Wittig not because of the books, but because of the annotations to the books. So it's very important, I think, to conceptualize through the marginalia.
Well, my favorite philosopher of science is Ludwig Fleck, and he says that our thinking is socially conditioned, so we have to think in some way. So how it is possible that sometimes we think about something new? And Fleck claims that the source of novelty are misunderstandings. And I think that your remark about Copernicus' mistake can be a good illustration to this Fleck's view. Yes, so misunderstandings can be fruitful in science.
Yes.
If I may, one comment about, while it is true that integral, whole, and part in a dialectical context is logical, Mariology has ontological implications. And so there are ontological assumptions. Oh, Mariology is that part of philosophy that deals with part-whole relationship. Excuse me. And it has ontological implications. So it's not, just the dialectical dimension to it. There is also an ontological dimension to it as well.
Because when I was reading your text about mereology, I was thinking that the same kind of argument we can find against Galileo. Because when you are arguing from the absurdity, it's like arguing from the whole against parts. Because you are talking about, the absurdity is like a monster in Copernicus. Because if something is a monster, it's absurd. So when you have, for example, people claiming that Galileo cannot prove anything, so he was condemned because his views from the point of view of philosophy were absurd. So this is the same kind of argument, but only the way we make this architectonic whole is completely different. So different parts and different relationships are deemed to be more important. So this is a very weak argumentation, I would say, not only because it was wrong logically. I don't know if you agree with this idea that thinking from the whole was very popular in these times. Right, that's right. So it's a kind of a part of the discarded world view. Do you agree?
Extremely briefly, there's a passage in Francesco Ingoli that writes a response to against Copernicus to the Roman Catholic. He's entrusted with the job of censorship essentially, and he writes something to Galileo, and he says the third and last of his argumenta physica, the physical arguments, is about the parts and the whole. Mm-hmm. And he says, Copernicus is erring because of that. And I know this is, I don't have time to look it up, but it's interesting that it comes back. So I think, and if you think of the Jesuits again, the Jesuits were Tychonian, even Bellarmine eventually adopted a Tychonic model. So there was a lot of freedom. It wasn't a problem of, they weren't bothered by going against traditional Aristotelian worldview, but it was really about this, as you said, there certain discussions originate in the classroom because of dialectical, rhetorical approaches, and then they take an ontological dimension, and Clavius is another good example. Clavius is pretty much responsible for the way Copernicus was received by the Jesuits. Interestingly, a mathematician, not a theologian.
Yep. Okay, so we can conclude this part that even from the error we can have true revolutionary ideas. So what happened with Copernicus, probably he became revolution against himself. So in a sense, okay, maybe just last thing about these collectives. We're talking. Do you really think that he was so solitary, or maybe this is only he was very sober in what he was writing? He has this kind of. He was not avoiding attributing maybe to others the sources, but just he thought it is unimportant in his book.
Copernicus' solitude explains why he worked for 40 years on his book. It's hard to understand, otherwise. I think that his sources of inspiration disappeared after 1503 when he moved to Warmia, and so he could only develop what he learned before.
Okay.
And
Just one comment on that. I once referred to him as a solitary networker, to use a modern expression. We know that he communicated with students that he had met in Krakow over the course of the early decades of the 16th century about observations, and that certainly later, the extent to which he relied on Rheticus to provide him with some information. So that on the one hand, yes, he worked alone, but he was in communication with other people. And it seems to me to a large extent he relied on them. And one has to keep in mind as well that as a physician, he was also very much involved in the political life of Varmia, the economic texts that he writes. So this was an involved, working, individual who was certainly in contact with other people. And I think Birkenmeier made a very important contribution in trying to locate and identify the individuals with whom Copernicus remained in contact and who were important for his own development and his own work.
Maybe one or two questions, very short questions from the audience, because we are closing in a few minutes.
The following problem, Krakow philosophy in 15th century was rather dominated by late scholasticism, not Aristotle. These masters came from Prague, was followers of Wycliffe and other. Is any something new known about influence of this kind of scholasticism on Copernicus?
Did you understand? The question was if, because there was a kind of late scholasticism taught in Krakow, there is an influence seen in Copernicus of this teaching.
Indeed. I think that when one looks at the text, even of De Revolutionibus, especially the first book, of course, it's clear that the language, much of the language that he adopts is the academic language of the university in the 1490s. And educated in that tradition, that he naturally thinks and writes in response to it. So he's not creating a new language altogether and not, creating new ideas, but adapting and responding to what he knows will be the greatest challenge of his theory, and that is dealing with the Aristotelians. So he has to use Aristotelian concepts, Aristotelian paradigms to respond.
But there is no philosophy in the Revolutionibus. Well, it is simply observations plus geometry. nothing more.
Stable. People at that time wanted to be original. There are several, in Italy, for example, controversies among mathematicians. Who was the first, who was original? Perhaps Copernicus was a typical scientist and he wanted to be original, so he didn't mention some people. So don't make him absolutely hero in scientific method. So for example, the case of Cardano, a mathematician, it was a very famous controversy about his achievements. He was mentioned or not, and so it was something typical at that time.
Any comments? That he wanted to be original, like many other authors of this time. That he wanted to be originals.
He created original system because he connected Aristarchus' ideas with mathematical techniques of Ptolemaios. So the result was original. It was a synthesis, and nobody made such synthesis before.
Okay, probably these are guesses. We don't have much information about what Copernicus was thinking. So we have only to guess. So I would like to thank our discussants. I think the presentations were extremely interesting from different points, but pointing to maybe to some aspects not very well known of Copernicus. So I would like to thank and to applaud our discussants. Thank you very much.